Today I'm going to be reviewing the basic differentiation formulas. Computing the derivative of a function directly from the definition of a derivative is oftentimes a tedious task. Fortunately for us, rules have been developed to simplify the task of differentiation. The first rule that I'm going to be reviewing is the rule that we use to find the derivative of a constant function. So for d, the derivative d dx of any number c is equal to 0. So an example would be if we're trying to find the derivative d dx of 2. So if we look back at the rule, 2 would be the c. So the derivative of 2 would be equal to 0. Another example of this would be if the d dx, the derivative of 100, is equal to 0. D dx, the derivative of 1000, is equal to 0. And d dx of 5000 is equal to 0. So the derivative of a constant function is d dx, the derivative of any number c, is equal to 0. The second rule that I'm going to be reviewing is called the power rule. So the power rule says that if n is a positive number or integer, then the derivative d dx of x to the n is equal to n times x to the n minus 1. So an example using the power rule would be if we're trying to find the derivative d dx of the function x to the 6th. Alright, so the derivative of x to the 6th would be 6, you move the power down, times x to the 6 minus 1. 6 minus 1 is 5, so it would be 6x to the 5th. That's your final answer. So another example of this would be if we're trying to find the derivative d dx of x to the 9 would be, the derivative would be, you move the power down, 9 times x to the 9 minus 1, which would be equal to 9 times x, and 9 minus 1 is 8, so 9x to the 8th. The third rule that I'm going to be reviewing is called the constant multiple rule. And that says if c is a constant and f is a differentiable function, then the derivative d dx of c times f of x is equal to c times the derivative d dx of f of x. Alright, so an example of this would be if we're trying to find the derivative d dx of the function 3x to the fourth. The derivative of 3x to the fourth would be the constant 3 times the derivative d dx of x to the fourth. And as we remember from the power rule, the derivative of x to the fourth would be 4, you move the 4 down, times x to the 4 minus 1, which would be 3. So we're going to take 3, the constant, times the derivative of x to the fourth, which is 4x minus 3, which is equal to 3 times 4 is 12, x to the third. And that's your final answer. A second example of this would be if we're trying to find the derivative of, say, 8x to the 10. Right, so we're going to take the constant, and the constant here is 8, times the derivative d dx of x to the 10. And then to find the derivative of x to the 10, we use the power rule. So it would be 8, the constant, times the power rule, which would be 10, move 10 down, x to the 10 minus 1, which would be 9. So that is equal to 80x to the 9. And that's your final answer. Alright, so those are just a few of the basic differentiation formulas that we use in calculus to find the derivative of a function. The first rule that I reviewed is the derivative of a constant function. The second rule that I used is how we find the derivative of a function using the power rule. The third rule that I used is how we find the derivative of a constant multiple function, and that's called the constant multiple rule. There are a few more rules that we use to find the derivative of more complex functions, but we will be discussing those at a later time. So I hope this video helped you, and keep studying.